So wiring diagrams, tracing current. First thing, this is somewhat a review, but when we look at this wiring diagram, you may call it a schematic. You may hear me call it an EWD. So there's a lot of things to call the same thing. EWD stands for electrical wiring diagram. A wiring schematic is pretty self-explanatory. It's like the schematics of the system. But basically, when we're looking at wiring diagrams, it's a map of all the electrical components and their connections. So remember way back in like the first week or two, we were talking about if you had an electrical component that didn't work, where would you start off? And people, DIY people tend to start off with, well, check the fuse and change the bulb if it's a bulb. And there's some logic in that. But if you really want to diagnose, you got to have a picture of all the parts of the system. So this is a really good starting place with electrical problems. For example, not every circuit has a fuse. And a lot of new cars have 3 or 4 different fuse boxes. So you may say, check the fuse and think that's easy, but check the fuse may turn into an hour-long ordeal. Come to find out that it's actually got a 4th fuse box in the trunk underneath a panel and you got to pull something. So you don't want to just go in there blind. Start with this and then you'll say, oh, it does have a fuse. And on that diagram, it'll tell you what size, what the location is. You can get a whole picture of all the other components. So let's say in there, you might have maybe it's going to show you how the battery interacts. Here's your fuse. If it has a fusible link, a circuit breaker. If it's got a single filament bulb, a dual filament bulb. If it's got a capacitor, a splice, a switch, a variable resistor, a transistor. If the wire goes over the top of another wire, those are not connected, right? So like this is going to give you a whole map of what you got. And there's even more. Thermistors or resistors, it tells you about the ground, and the ground symbol can vary. So back in the day, they used to look more like this or this, and on some of the new stuff, especially domestics, they look like this. So it can vary. You got to be kind of like adaptable. Even a motor, for example. So if we're diagnosing a power window, you'll see a symbol that looks like this. That's the power window motor. And then you may see relays, diodes. I want to point something out right here. This is a connector. And this connector, sometimes people will call it like a chevron. You know the chevron symbol? It's like the 2 arrows. If you look, this has kind of like an arrow. The one that's pointy is a male, and the one that's kind of like the receiver is the female. You can imagine how they came up with that, and I think we'll just keep moving on. And so if you look at this connector, you'll be like, it looks, you know, on the boards, everything is clean and clear because you can see where it goes. But on the car, if you're going to test a wiring diagram and you're going to test right in the middle of the car, you'll find the connector, but you don't really know, like, behind the panels, does it go this way? Or, you know, if it's this way, does the front go to the back? Or you don't really know. This is going to tell you which direction, right? So if on the diagram, it shows the battery on top and it shows the male on top, so then you would actually know if you found that connector, the male terminal is coming from the battery and the female terminal is, let's say, going towards the ground, right? So this tells you a lot more than you think. And then there's different types of switches, LEDs, solenoids, all sorts of things. Cool, so we're going to see those on our diagrams. For example, here's a diagram and we'll just apply some of those components. Does anybody remember what this is?
Battery.
Yeah, exactly, that's your battery. That doesn't look like a battery to me. What the heck is that?
It almost looks like a ground.
That almost looks like a not a double-double, but like an 8x8 or something. Like, look at it. The reason why is because, give you a little head start on batteries. Inside the battery, there's all these plates. Now, look at those plates. Doesn't that kind of look like the plates? So they're just showing it's like the plates of a battery. Kind of a weird symbol, but the other thing that's important for you to know is these are global. So, you know, so they won't necessarily write like BAT. Like they could do a box with BAT, but in Spanish, what's BAT? Be like, what would you put? The pila? So it's a lot of symbols. There's not a lot of letters and words. because they only print one wiring diagram like this. Okay, and then from there, do you guys see this little dot? What do you think that means?
Split.
Yeah, they call it a splice. Exactly. So what a splice means is those are connected together. If you just see them go cross each other, first off, there'd be no reason for it to go there unless we had more of a diagram up there. But if we had more of a diagram and you just saw it breeze over, sometimes they'll make this little, like a little hop looking thing. It'll look like it jumped over it. Those are not connected. Electrically, it's very different. They may cross each other on the paper, but not be connected. The fact that there's a dot right there, that's a splice. Those are connected. Make sense? Do you guys remember this symbol, these symbols? Fuse of those may be fusible links, but some sort of circuit protection device. It's not totally critical for us to know which one it is, because we'll find out. Okay, and then I want to point something out. Do you see the W? What do you think that means?
White.
Yeah, it's telling you the wire color. So when you're trying to find this on the car, you need to know what color the wire is. Make sense? Then it's going to tell you the number of the fuse. So remember in the last thing we said, oh yeah, check the fuse, right? It's a good idea. Which one? There's 100. So which one in this case?
19.
Yeah, 19 or maybe 10, depending on exactly what we got going on. So this diagram is giving you whole massive bunches of information. What fuse? Now in this case, it doesn't tell you which fuse box, but sometimes it will. It may say something like the underhood junction box. And you're like, junction box, JB or something. That's really like that's a fuse box, but it's also a junction for other wires to tie into each other. And where was it? Under hood. So get out of the dashboard. It's under the hood. Go ahead.
Is there only 2 spots of fuses, boxes,
No.
cars?
No. Any car is different. And so if you ask me something specific, I probably won't even know offhand unless I've worked on it recently, because now if it's let's say it's a Honda Accord. Yeah, all the Honda Accords in 2025 are going to have the same fuse boxes. But if they do a redesign in 2026, I don't know. I have no idea. They may add one, remove one, combine, who knows? So every car could be totally different. Whereas back in the day, you guys like some classic cars? Yeah, there was one fuse box and it had 10 fuses in it. And that's where it was located and everybody knew where it was and it was like really easy to get to. But on new cars, what they've been doing is adding more and more and more because we have a lot more electronics, right? And they've even done some things where, let's say it's a body control module. That's a computer, right? But the back side of the computer will also be a junction box with fuses in it. So now you have a BCM plus a junction box plus a fuse box all in one, and it's under the dash and you got to pull a panel off to even see it. You'd have no idea it's even there. So no, it's much more complicated to find a fuse than it used to be. That's why you absolutely need this wiring diagram. So let's say from here, who thinks they might know what that means? That one's kind of weird, huh?
The arrow going down?
This number 1 going to the right and this number 2 going to the right.
Continuation. Ground?
Good guesses. If that's a ground, then what's that?
That's ground.
And that makes sense because see the wire color? White and black is pretty common for grounds depending on the vehicle. This is actually saying there's more to this diagram, but it's on another page. So you pull up page 2, and if you were to lay page 2 like this, there will be a 1 with an arrow this way, and you'll see that the 1s connect, and you can see this circuit keeps going on to something else. So you may have multiple pages. So if you get a really complicated problem, you may need to print a bunch of pages, and sometimes what I'll do is I'll print them and I'll cut off like the border that it doesn't print on. I'll cut that off so I can get them to touch, and I'll tape them, and next thing you know, I got something as long as this table, and I'll be like, the wire starts there, and then the wire goes over here, so it can get kind of complex. It's frustrating when you're on something like All Data because you look at this one and then you want to know what else is there, and you have to like exit the page and go to the next page and pull that page up, and then you're looking at the first page and then the second page, and so there's few times where I'll really be insistent on printing. I like the electronic copies. With wiring diagrams, you're probably going to end up wanting to print these, especially when you're new. It's a good idea to print them, and then if there's multiple pages to snip them together and just get a good It'll make it easier on yourself to understand it. You don't have to make it harder. Cool? Okay, so let's go down from there. These are labeled, but you guys can tell me what they are.
Relays?
Yeah, 2 relays right there. So we talked a bit about relays. Then we got some more fuses. What do you know about these things here?
Bulbs.
Yeah, different bulbs though, but bulbs, I agree. How about this one is also labeled, but kind of a little hard to understand. So let's look at this one a little better.
It's a switch.
It is a switch, but it looks like there's 2, huh? So it's like, it's a double switch.
High
beams and low beams.
Yeah.
In this case, let me take a look at this. Actually, it's not high beams, low beams. So this is what I'll do. We'll do a quick trace, which wasn't exactly the original plan, but I'm cool with it. Let me make sure this is out of the way, because for now we're just going to look at the symbols. But I'll show you how if you can't totally see what it is, sometimes you could start with like, the battery's going to put out positive, so we're going to make that red. We're going to bring it over here. It's going to do some stuff. And then same with this one, right? It's going to do some stuff depending on what's going on. Then what I kind of want to do is focus on what's happening down here. This is grounded, right? We'll bring it up and bring it over. And that's it. The ground is pretty much not going to go any further unless we turn the switch on. And then what do you think happens to these 2 things?
Connect.
Yeah, exactly. They close like this. So ground would make it to here. And then let's just overall follow and see what ground is trying to do here.
Turn on your headlights as well as your tail lights.
Exactly. Yep, exactly. Right. So sometimes I'll just sketch some stuff in right here. If this is a ground and this is a ground, and actually there's a lot going on in this diagram. This is not a diagram I'd ever start with, but now that you're kind of seeing, that switch is controlling 2 relays. The relays are the headlight relay and the taillight relay. So it's kind of interesting to think you've got a fuse for the headlights and you've got a fuse for the taillights, but when you turn your headlights on, don't you want your taillights too? Do you want to have to do you want to tell the customer, hey, you need to turn your headlight switch on and your taillight switch on? No. Just put it in one. So they build the switch into one housing. You turn one switch, but it actually does, it's got a double throw. Make sense? So you look at that, they control a relay. Now we could totally trace this diagram, but this is not the diagram we start on. So we're gonna start on much more of a basic diagram to get started. But this is not an abnormal diagram. This is a diagram that you'd see, if you had to troubleshoot. Okay, but wait, there's more. We've got the switch, right? We've got a different type of switch. We've got another set of bulbs here. We've got a ground here. We've also got, let's just pick one wire. We've got this LG, what do you think it stands for? A light green wire from the relay to the switch. So for whatever reason you're troubleshooting this circuit and maybe the relay's not clicking and you've done several steps, you wouldn't just jump to this, and you think that this relay is not getting a signal from the switch, that's what you'd test. You'd say, all right, this switch should provide ground to the light green. How do I test it? I find this connector, see the chevron, right? So I'd probably back probe the female connector, and then see if when I turn the switch, if it gets ground or not. And then here's where we'll tie it together. If it gets ground right here, then I'd be like, okay, but does it get ground right here? And let's say it was a no. If it had ground down here, but the ground didn't make it up to the relay, what do you think? It's something between the two. Bingo. So it's no different than everything we did on the board, except you can't see it. Like if you go under here, this is the light switch, that's in the column. So you're under, near the dash, by the seat, upside down, probing. And then you're like, okay, it's got ground there. Then you might have to go outside the vehicle under the hood and look in the underhood junction box and be testing at this point. You can't see that wire. That wire is like basically, it goes into a conduit, into a harness, and it's just gone. It's gone. It's somewhere.
But then if you have to replace a wire,
could.
you replace the harness instead.
Okay, I'll bite. So this is the harness and repair stuff is the second half, but what I need for sure at this stage is a diagnosis. If you can give me a diagnosis and be like, it's the light green wire from terminal 2 of the light switch to the light green wire at the control side of the relay, cool, we're done. That's all I'm trying to get you right now. Now, I'll give you different situations. Let's just say Jerry's in the military and he reports that to the colonel or whoever's in charge. The colonel will probably at that point say like, replace the harness, or maybe they'll say like, well, what should we do? And Jerry might be like, well, I think we should replace the wire, right? So it kind of depends on the situation, but if you give me an accurate diagnosis that it's that wire, we can fix it. Now let's just say it was Gregorio, and Gregorio's at the independent shop, and the independent shop calls the customer and they say, hey, we found your problem. The reason that your tail lights won't work is this light green wire and the thing and the whatever. And we're going to give you 2 options. One is the recommended fix, that's replace the harness. And the second option is we'll go a little bit further into the harness and we'll find, if a mouse chewed it or if it rubbed through, and we'll repair the harness, and we'll guarantee that work, but we'd really recommend replacing the harness, right? So there's a range of potential repairs. And then let's say Refugio, because you asked it. Let's say you're at the dealership. What company? You pick it. All right, it's Toyota dealer. Matter of fact, I can tell you what they'll do. If this car is damaged like that, they'll go into the parts department and they'll say, hey, I need a price on this harness. And then they'll present the price to the customer. And the customer will be like, what? It's $3,000? And they'll say, yeah. And they won't offer them, most likely, they're not going to offer them a let me repair the harness. They'll sell the whole harness. What if you sell a $3,000 harness and it doesn't fix the problem? It's happened. That's why I'm saying I need the diagnosis to be accurate. Don't you tell me like, oh, well, it's probably the harness. Let me sell it. It's $3,000. Make sense? So in either way, the diagnosis must be accurate because one, the harness is expensive and you don't want to waste a customer's money because of incompetence and a misdiagnosis. And in the other scenario, let's say that we fix the individual wire to save them money because we're at the independent shop and we're trying to, independent shops they're trying to be competitive with pricing and give customers a lot of TLC and be more personable. You say, hey, we need to fix that wire. Well, you actually have to find the break in the wire then. So if your diagnosis was incorrect and you spend the next 3 hours trying to take this harness apart and trace it and check where it goes through the firewall, and then it was behind the front bumper cover, and then it was, if you come to find out that there's nothing wrong with that wire due to a misdiagnosis, you screwed up again. So either way, the diagnosis has to be accurate the first time. Make sense? And then do not revert back to DIY style. DIY style is, well, it could be the wire, so let me just cut this harness all up and look for a break in the wire. You can't do that. That's going to be like hours and hours. You need to get good with your meter and testing. If you're a little nervous, let's say we talked about, right, it should have a ground here, and the ground should make it to here. If it had the ground here, but it didn't have the ground here, it's a broken wire. But let's just say you're like, man, I'm nervous. That harness is $3,000. Cool. Put your meter on resistance and check ohms, check for continuity, check the resistance from these 2 points. And if it says, oh, well, you just double checked yourself and you're like, no, that wire's open for sure. That's okay. Measure twice, cut wrong twice. No. That's not how it goes. Measure twice. Oh yeah, cut once. That's how it is. I thought it was different. All right, so double check your measurement, make sure then you can figure out what the treatment is for the patient. Make sense? So from there, that's mostly what you need. In some of the diagrams, these will have terminal numbers, and that's helpful, but we're getting into that. All right, so remember, there's going to be symbols to represent circuits and connections and components and relationships. So you do need to know what the symbols mean. Sometimes, like on all data, you're going to just get a piece. It's probably not going to have the key, like the symbol key, but on some they will, and I actually have one later I'll show you. And then the other thing to remember is a single wiring diagram for the whole vehicle would be way too confusing. So if you want the wiring diagram, you're going to have to print it on a piece of paper as big as this room. And when you want to diagnose it, you're going to have to walk around and follow it. So what they do is they'll basically extract the wiring diagram for one particular system or component. So that previous one, what was that previous wiring diagram about?
Light bulbs.
True, but there's a lot of light bulbs in the car.
Battery.
Well, it's not a battery diagram.
That's the
Exactly. And mostly, if you actually look, it looks like they're really mostly focused on the taillights, but because the headlights are a part of the taillights, they'll show a section of it. But if you notice, the headlight relay went, let me take a look here, this way. Oh yeah, you're right. There's definitely headlights there. The taillight relay,
back. That's what the
the taillight relay didn't connect. So you're right. Those are the headlights. Actually, the taillight diagram would be over here. So this is mainly headlights. See, you found it. That was good. If you're diagnosing headlights, this is the perfect diagram. If you're diagnosing taillights, this may be half of the diagram you need, and you may need the other half. But if they showed every single light on the car, there'd be like interior lamps, and there might be instrument panel backlighting, and there might be radio illumination, and this wiring diagram would just be too big. Okay, so they'll take a piece, they'll pull it off, and then they'll make it so you can get the whole picture if you need to by taping another one up next to it and taping a bunch of them together. But trust me, you don't want the whole thing. I'm just letting you know. Cool. Not on a new car, you don't. Okay. And then to reiterate, wiring diagrams contain large amounts of information. So if we were to jump back on that one, you'd be like, whatever, it's just a wiring diagram. But it's kind of like in construction, you know, that the plans or the blueprint, that contains a ton of information. So, you know, to like the homeowner, they'll be like, oh yeah, that's what the house is going to look like. And then every other page like, But to the contractor, you know, that's going to show the scale, you know, like in the framing plan, it's going to show what type of board they should use, how long it should be, what the spacing should be, what type of nails or screws they should use. There's tons of information on plans or like blueprints. This is like our blueprint right here. This has a lot of information for us, and we kind of covered some of the different aspects. All right, so remember, your job now is going to be interpret the symbols and the connections, and then kind of relate them to how the components are, mostly because we need to do diagnosis. So the customer never comes in and they're like, hey, just take a look at my wiring diagram. You know, the only time we're going to look at this is something don't work. The tail light doesn't work, and the lube tech's already put a bulb in it, and it still doesn't work. You get the diagram out, and you understand all the aspects. And then every manufacturer does supply a key for the diagrams that lists the symbols and what they do and what they mean and et cetera. So like, for example, if we had a wiring diagram and the wire color said L, what do you think that means? L. So like B is black or blue. Most manufacturers, B would be blue, but it could be black. BL could be black or blue. BLK, definitely black. BLU, definitely blue. What the heck is L? Light blue or lavender, you know, so one manufacturer like Domestics will not use L. They're like, no, we're not doing light blue because we don't, and if they do, they'll say LT, BLU. So they do vary from one manufacturer to the next, which is why this is saying, if you're not sure, you got to find the key. The key might be hard to find though. I'm sorry. I'm going to give you some Toyota sample ones because Toyota's pretty good about making it accessible, but I've worked on some German stuff where like, it just doesn't, the key's somewhere, but apparently the Germans wanted so much money, all data didn't pay it. And they're like, you do it with no key. You don't get the key. So you got to kind of guess. But what's also really helpful, the connectors and the pin numbers. So pins is like a terminal. So I actually brought a connector just so you're clear. Like this connector, I think this is actually an injector connector. You see there's two little spots in there. This is a connector, so this may be C 104, which would be connector 104. But then in here, there's a terminal and a terminal. It may be A and B. It may be 1 and 2. And those terminals, I actually brought a few just so you can see. I brought them in my pocket, which is, again, part of the next unit, but they relate really closely together, so it's a good time to cover it. You see this tiny little thing? That tiny thing? This is a terminal. This is 2 terminals. These 2 terminals would be inserted into that connector. So if it has a terminal number of 1, you're going to actually have to look really close on the connector and be like, which one is number 1? The terminal will most likely be labeled, but on some manufacturers, they don't label them, which is why pretty soon I'm going to show you connector end view. So when you look at that diagram, it's not quite as apparent where you need to be probing as you'd think. And if you probe the wrong spot, you're not going to get a reading that's accurate, right? So we look at this. Remember right here, we are expecting to have a ground here with the switch on. Well, if you're probing some other wire that's unrelated, you're going to be like, there's no ground. It's a bad switch. And then you price the switch, sell the switch, bill the customer the money, put the switch in, and it doesn't fix it. And then you come to find out you were supposed to be on terminal 2, but you accidentally probed terminal 3. Go ahead.
Why are connectors so dang expensive though? I rebuilt an engine like 2 years ago, right? And I bought the harness, but the harness I had bought was used, so the connectors were already
messed up.
Weathered.
Oh yeah,
You know, so they
yeah,
easy.
yeah.
So I had to replace the connectors, and that was so expensive for those connectors, for all the connectors.
I don't think there's a good reason for them to be expensive. Quite honest, this doesn't look expensive to me.
Yeah.
But a lot of times they're hard to get. So it seems to me like I saw a company called oeconnectors.com. And I think mostly the reason is it takes someone a lot of time to figure out what specific connector and what the terminals and whatever. So I don't think you're paying as much for the material as you are for some poor fool who made it so that they organized everything so you could actually order it. So the cheap way to do a connector is if you go to the Yonke yard and you just cut that sucker off. But the junkyard ones are probably already beat up. Kind of rough, huh?
Replaced one on my Escalade.
Yeah.
Because we were changing the what's it called, the cables to the spark plugs, right?
Okay.
So
Yeah. Sure.
I ended up messing up one of the main connectors, and it was just one. So
Yeah.
what they did, I had to order it because my car didn't even start without that connector, right?
Sure.
So
Yeah.
I had to order it from O'Reilly's, and just it was spliced, you know. So we had to splice.
I know just what you got.
And
Yeah.
that thing cost me like about I think it was close to $200, and it was just from the little connector itself, and
Yeah.
like 4 inches of wire, and I had to splice it myself and do that. And I'm like, what the heck?
So I'm going to show you guys something that's a little slightly off topic, but good. So let's say that you did have an issue with one of those connectors, right? Just for reference, if this is terminals 1, 2, and 3, or A, B, and C, our focus mainly now is that we need to probe these and test them. But just so you understand, if one of these gets messed up, you can buy a pigtail like this, but it's hard to find out which one it is. And actually, Amazon, sometimes they can be kind of reasonable, but still $10 for that still seems a little expensive.
Because that specific connector that messed up on mine, it had the harness itself, the wiring was like about 10 wires. So if I mixed
yeah.
wire, it was like very like intimidating. You know?
No, for sure. Those can be tough repairs. So if you really wanted to be scared, let me look at like a ECM pigtail.
No.
So when you get into stuff like these, you know, this is actually this is actually one of the ones that goes to one of the different ECM connectors. Like here's one. All right, so as we get more into connectors and terminals, we'll cover this more in detail. But when you're looking to do the diagnosis, there's all these connectors on that wiring diagram. It may say, this might be wiring diagram connector C1 on the ECM and C2 on the ECM. And if it says C2 terminal 49, you're gonna have to be like, okay, that's C1, that's C2. A lot of times it'll say C1 red and C2 blue, and then you'd have to determine which one it is. So I'll be super blunt with you. This is like my least favorite part of diagnosing electrical concerns. The measurements and stuff are cool, but like trying to dig through the diagram and find out the terminal number, and then if the terminal number is 49, you might be able to figure it out if it's labeled really small, but other times you'll have to get an end view of this and it'll show you which spot it'll actually be in. And you need to make sure you're on the right spot, because there's some rare instances where, let's just say right here, let's say this was terminal 1 and it says G for green, but I've seen like some of the manufacturers, I especially used to see it on the Koreans when they were trying to bring up their brands. I don't know if their companies ran out of green or whatever, but next thing you know, that wire's white. I'm looking in there like, that ain't supposed to be white, that's supposed to be green. The terminal number takes precedence. The color is a convenience factor. The color should be accurate, but the terminal number is always accurate. And then also, just as a side note, like a pro tip, if the wire color doesn't match, double check and make sure you have the right model year and engine, because on one engine it might be a white wire and on one engine it might be a green wire. And if you think it's got the V6 but it's actually got the 4-cylinder, you might be like, whoa, I'm on the wrong diagram. You could be real quick way down a rabbit hole, off in the weeds, lost, and electrical's so complicated because like one little tiny mistake. Cool. So the terminal numbers take precedence. I'm like, Priscilla, you've done some stuff on your home side work. That's pretty good. So further, and we will come back to connectors like in detail, I promise you. So remember, the diagrams show straight lines with numbers, color codes, letters, sometimes even show size, wires. And then when we talked about those splices, remember there was that dot? That's the splice on the diagram, but how it looks may vary. Sometimes on the diagram they come together like this, but on the car it's two wires that come together like this, and then they're like crimped together or soldered, so the splice doesn't look in real life how it looks on the diagram. Cool. Like for example, they may have that black dot like we were talking about. Other times it may have an S next to it, and the S meaning splice, and that S may have a number, splice 107. So you may see like a whole bunch of grounds come together at one point at splice 107. And if you think there's an issue with splice 107, you can locate splice 107. Where is that? And it's like, it's under the dash. You got to pull the dashboard out. And you're like, no. Okay, but at least you need to know where it's at. Makes sense? They will label those. And then kind of like I had already mentioned, if the wires pass over one another but they don't connect, a lot of times they'll do like a little hop or a little U, they'll go under. And once in a while, they will show the wire size, but unfortunately not always. Why do you think this is critical? Why do you think it'd be really important to know the wire size? All right, so let's just say it was a big wire and we put a small wire in. Why is that scary? Yeah, the amps, it's kind of like the wire needs to be able to carry the correct number of amps, otherwise it can overheat and catch fire and burn the family alive inside. Okay, that's kind of how we do some stuff. So there with the splices. See, these are spliced, right? Splice, splice, splice. S102, for example. Now, these look like they're right next to each other, don't they? On the car, they may not even be remotely next to each other. It's just on the diagram, that's how it's drawn. Cool? And then look right here. The wires cross right here, but you notice there's no dot. Those are not connected, so don't assume they're connected. They're not. These don't even have the little hop over thing. They just don't have the dots, so that's how you know. Right, so that was zoomed in, showing you the splices. And then, like for example, these are some of the color codes. BL being blue, which I don't really like. I would prefer BLU, because if you saw BL, that could be black, right? So I don't really like that. But then BK is not Burger King. You can't have it your way. It's just black. That just happened. And on a lot of cars, black is ground. But on some cars, white with black is ground, or black with white is ground. And on other cars, green is ground. So it really depends.
I've even seen dark, like a Dodger blue as brown.
They could do any color.
I'm mistaken.
But they could.
I've seen using that as what's it called?
A positive.
Yeah, as positive.
They could do any colors. So like it's cool when you work on the same stuff because you're like, oh, like now you're getting into the brain of the engineer. The brain of the engineer is, oh, we'll make all these colors grounds, and we'll make all these colors positive. So like you'd think red is probably going to be power, right, or positive, but not necessarily. Although I don't know that I've ever seen a red as ground. I have seen black as positive. So a lot of different colors here. Like LG would be light green. And in this case, see, it doesn't even show an L. So this is definitely not Toyota specific. Once in a while, you'll see diagrams that'll actually color the wires on the diagram. And it's kind of nice, right? You could tell this is orange with a yellow marker, right? So you'd see like OR/.
It's red.
All right, fine.
R and Y.
Okay, so then you might see like wherever red is, RD/YL. So that would mean red with a yellow marker, right? And again, that's mainly for your convenience. It's 99.7-ish% accurate that the wire color will be accurate. Once in a great while, not so much. And then you remember I showed you those pigtails from Amazon? Did you notice those wire colors weren't the same? So sometimes when you do a wire repair, they don't come with the correct colors. So that's where I'm saying, like, you do have to know the terminal, not just the color. Cool? But what's nice about the color, let's say that this, yeah, you're right, RY. Let's say that this came from this terminal, and then you're inspecting the wire, and like maybe 6 inches away, you see a red and yellow wire that's cut. You'd be like, okay, yeah, that's it, because that's the right wire color. So it's helpful, but just know you really want to verify the terminal number. Cool. And then sometimes they'll call this a tracer. So this would be red with a yellow tracer. Sometimes they'll do it like that.
So that one that's on there would be in terminal 4?
Well, in this case, it didn't really show us, and we do get a little bit more in. I'll show you the ones with the terminals, and then I think it'll click.
Is that a terminal, or are those connectors?
Every connector has terminals in it. So this is a connector. It's a plastic housing.
Okay.
And inside, these are terminals. And the way that they're placed into the connector is kind of like their number. So like, to be honest with you, this might be 1 and this might be 2, but maybe this one's 1 and this one's 2. I really don't know. So if I were to look at this really carefully, I might find a number. Yes, and I did actually. I'll show you guys a little bit later, but there's a number 1 and a number 2 on this, but it's a little hard to see. Like I doubt I can even get it on camera. So I'm gonna go ahead and take the opportunity to pass it around. And if you guys got your eyesight if your eyesight's sharp, you'll see it. Cool. So from there, you'll be able to tell which one's 1 or 2. So you're not probing the wrong one. Cool. And also when it's let's say it's a RY, that means the wire's red with a yellow tracer. If it's YR, don't look at the red with yellow, look for a yellow, more yellow with a little red. Makes sense? So the order of the colors are important. Cool. And then the other thing is, like a lot of times on the diagram, you'll see it just goes to ground. And you're like, what the heck is that? Well, that's a lot of times where they'll take it and they'll basically crimp the wire to it, and they'll send it on like an eyelet terminal to ground, and they'll put a bolt in there, and that's how it gets grounded. And a lot of times there's redundancies. So they might ground it in several different spots. Why do you think they might want to ground it in several spots?
So they have more ground than just one spot?
Yeah, like if one gets messed up, we have a secondary one just in case, So we do like to have redundancies, and remember the whole chassis is grounded. If the whole chassis is grounded, it's pretty easy to just be like, yeah, just pull it over and ground it. Bang, right there. Look, ground it again, just because. So we used to have problems with grounds, and then it would cause a lot of issues. And then one way was to repair the ground, and another way was make another ground, and it'll be like a backup. So they started doing that more from the factory.
Oh, side question.
Sure, go ahead.
How do you remove this connector?
Second half of the class.
There you go.
All right, but you guys see this one. Now this is a connector here. This is JC junction connector. number S16, and terminal 1 and terminal 2 and terminal 3. So you can see these actually have the terminals listed. So that makes it kind of nice. Now the reason it's really critical is it the red wire? Terminal 2.
Yeah.
Yes. Yes. Yeah. But which one? They're all red. So see, you gotta be able to locate the terminal. In this case, exactly right. Bingo. So if you're probing this one and you're getting a reading, like let's just say inside the junction connector, something fails. And let's say there's supposed to be, I'm going to use terminology I'm not totally comfortable with, but I'm going to make it simple. There's supposed to be power at 1, 2, and 3. And wherever 2 goes doesn't have power. You want to know if it's getting power out of JC16, right? So you go to probe it and you're like, oh, it's the red wire. Next thing you know, you're probed on terminal 1. You're like, yep, it's got power. But you're supposed to be on terminal 2. And after diagnosing wrong and coming back to the job, you realize that terminal 2 had no power. You were on the wrong number, but it was red, so, oh no. And they're like, we're going to spend our life savings to fix this. And it was wrong. It was a misdiagnosis. Make sense? And that does happen. Oh, and also if you look at the left rear combination lamp, this is connector S3 with terminal 1 white and black and terminal 2 red. So see, out here, this would be easier. Like in this case, if I was diagnosing this bulb and I just wanted to check for power, I would just be like, oh, that's the red one. And I would go ahead and I'd really carefully back probe with a T-pin and I'd check my available voltage and it should be 12.6. Make sense? But if there was colors that weren't really like, I wasn't super confident, I might be like, no, let me look at the connector real close and find the terminal 2. But if I see a taillight and it's red and white and black, like I know which one's 12 volts. It's the red one. Technically though, I'm bending the rule right there because what should I really should be doing? I should locate terminal 2 with a magnifying glass looking really close and make sure I'm on terminal 2 and then check terminal 1 should be grounded. Kind of make sense? That's a simple one, 2-wire. Cool. And then the other thing that they'll do, not on all, but on some, is they'll give you this number. So you guys, now that you know terminals, we've got, this is a body control module. We'll call the BCM from now on. At connector X6, terminal 3, there's a black wire, and that is the ground to the BCM. And that ground goes up and over and around, and it goes to G307, which is going to be actually like an eyelet terminal bolted to the chassis, bolted to the body. Make sense? Why do you think they'd give you this number right here? 1650.
Wire size?
It's not the size. Good guess. This is the circuit number. Each wire in part of a circuit is labeled with a circuit number to make tracing the wire easier. So if you're flipping multiple pages and on a different page you see 1650, you're like, oh, that's the same circuit. That's the same wire. So if this has to extend multiple pages and it says 1650 on one page and another page, those are the same wires or at least part of the same circuit, which means we might have another black wire spliced in. Make sense? And the other thing that I found that's really convenient with this is, let's say you get to the point where you're working for a manufacturer, like a dealership, and you need technical assistance because there's some abstract issue. If you were to call the technical assistance center and you were to say, yeah, I'm checking the wire, and they'll be like, what wire? Now you answer me, what wire? Circuit 1650, like, okay, I got you. Not the black one, the black one. There's a lot of the black ones. Makes sense? So this is helpful, but I gotta tell you, it's not every wiring diagram includes that because not every manufacturer does that. But if you do, it's pretty good. Okay, then remember, C is generally a connector, but like with these X's, I don't know, for some reason on a lot of modules, they'll have like connector X1, X2, X3, X4. Again, this allegedly has 7 connectors, so that's kind of nuts. And then fun fact on here, this is a computer and it's actually telling you what's going on inside the computer. So what do you think is right here?
Ground.
Yeah, but the ground doesn't originate here. The ground originates here, and this wire provides ground for that computer to work right there. So that's why it's nice when they have this labeled. Now, what do you think this is? Exactly, so that's your battery positive. Where do you think this comes from? If it's red with violet, terminal 2640, terminal 4 of connector X5, and it's providing B plus to the module. Where do you think this comes from? Exactly, yeah. One way or another. So all the positives, if you think about it, all start at the battery, and all the negatives all end at the battery. Even if it goes to the chassis, it bolts into the chassis, eventually it's going to make its way to the battery. The battery's got the negative terminal. It has a little jumper that goes to the body or the frame right there. So it all ends up there. So ultimately this will make its way to the battery, but before the electrons leaving the battery make it there, they probably have to go through a fuse and through some junction and through something and through some whatever, and you know, there's a whole path. So let's just say, all right, this one's given a jump, but I'm justifying why you need to know this. This body control module computer won't power up. BCM is offline. You can't communicate with the BCM. The BCM's job is to control a whole bunch of lights. It controls windows sometimes. It controls a bunch of stuff. The computer won't power up. What wrong? Anybody for replace the BCM? People will do it. People will be like, replace that BCM. Bam! And it didn't fix it. Ooh. We should probably replace it one more time just in case that one was bad. It's likely to have 2 bad BCMs, but the third one's not likely. Like, no, that was a joke. So the thing is, this computer, and really all computers, need a few things to work. They need power, and they need ground. So if that computer's not working, one of the first things I'll do is I'll be like, where's the power source at? Oh, I look it up. Diagram says terminal X, connector X5, terminal number 4, and I'll probe right there, and what should I get? 12.6-ish or whatever the battery is, cool? And if I don't have power there, what's that tell me?
The wire's messed up.
Something's going on in the circuit, right? And then I might have to look at another page and find out, where does this red and violet come from? What fuse does it go through? What junction box does it go through? How does it get here? Cool? Now let's just say, I'll even give you another scenario. Let's just say the B plus is good. It needs ground, right, to work. So then I probe right here. What should I get here? Yeah, like 0 volts, like a good ground. There's a couple ways to check it, but if I don't have a good ground here, then what do I do?
Change the wire.
Maybe.
Change the ground.
Test it. How can I test it further to know? Because I could have a bad wire, right, but I could also have a bad ground connection.
Resistance?
You could test resistance, but probably the logical thing, because I already have my meter on voltage, I should have 0 volts here, but let's say I don't, and I go back here, and this one has a clean, good ground, 0 volts. Then I'm like, well, if this ground is good, but it's not making it to there, I know it's this wire, circuit 1650. Make sense? That's how you get the real diagnosis. Cool? That's how you don't sell a BCM when it doesn't need a BCM. Makes sense? This is what we have to do. But it takes time, and it's a pain in the butt. And you got to know the terminal number, and then you got to get up there upside down with your flashlight on and find terminal number 3 in connector X6, and you're like, is that it? And I'm like, yeah, that's it. It's black. That makes sense. Test it, right? So it's hard to get to that point, but actually, it's not rocket science. It's just sometimes you got to do a lot of research, right? Here's a quote that I heard last week in one of our meetings. Ready? Engage brain before hands. Engage brain before hands. You don't get to just go poke a bunch of stuff. You got to be like, this is the part I hate. Get the wiring diagram, study it, understand it, predict what voltage should be there. Yes, and then engage hands and go see if it has ground or not. Cool, makes sense? All right, now let's just say I'm going to give you a real head scratcher here. If I came to the school and I logged in on my computer to the network and I'm able to talk with every computer inside this building, except for one, what do you think could be causing that?
The one computer.
Okay, the one computer might not be turned on, right? So if you call IT department to fix your computer and it's because you didn't push the power button, you're fired. But there's no power button on these. They turn themselves on. But what if the computer is disconnected from the power outlet, from the outlet and the receptacle, if you will? Wouldn't that make that computer go offline? So what I just said to diagnose the computer, this is the power source. Making sure it has B plus and ground. Cool. What all is going on over here? What do you think these are? Close. So you guys remember back in the day when you used to have to plug your computer into a cable to get internet? Like a LAN cable, Ethernet cable, these types of things. On the cars, most of these, almost 99% are not wireless. Wireless has some security issues. If I could hack into your wireless of your vehicle and make the steering wheel turn right and make your gas pedal go to the floor, you die. So they're like, no. We're not going to do wireless module to module communication. So these are still hardwired, just like old school. Not like AOL, like, only a few of you got that. But like really similar actually to like LAN internet, like the yellow cable or the blue cable. So this one is called serial data. This is the network connection to the computer. Right? So if the computer has the B plus and it has the ground, but it still won't communicate, there's one more thing I have to do. I have to make sure this is getting little pulses of information and this is getting little pulses of information. And that's something you guys don't cover like usually until the end of electrical 2. However, the reason I bring it up now, if I teach you that skill, like, hey, here's how you test for communication. You're going to use the picoscope or the oscilloscope and you're going to look for little pulses. And you'd be like, what's that pulse mean? And you know what I'm going to tell you? I don't have any damn idea. I don't speak computer. It's got a bunch of pulses. All I can tell you is those pulses get translated into hexadecimal information that means something, but I don't interpret it. But what I do need to do, if I want to see if the computer is receiving pulses and giving pulses, I need to be able to probe. Which wires should I probe to check for communication? You think I should check here for communication? That's for power. This should be 24 and 25. Exactly. That's what I'm trying to give you. I don't need you to be able to do that right now, but what I need you to do is when you learn about checking for communication, don't be like, where do I probe this? Be like, look at the diagram. It says right here, serial. It's 24 and 25. That's where the communication's occurring, right? So this doesn't change. How we test in here, that does. But the terminals and the numbers, that's what I'm trying to get you right now. Cool, so go ahead, shoot it.
If you want to find out why a connector is labeled X instead of C, I have an answer for you.
I would love to know. I've never even considered it.
X, it's Greek. So
I don't like Greeks.
Literally. So C, the letter C in Greek is X.
No kidding.
Chi.
Wow, that's
X is called Chi.
Oh wow.
In Greek.
Huh.
Hence, when you say Christmas is Xmas.
Never knew that. I thought it was just to shorten it up because people were lazy.
No, the reason they call Christmas Xmas is because Christ in Greek is Christos. Christos starts with an X.
Oh wow.
So when
Christos
we see an X there, it actually means C.
Wow.
Some crazy engineer loves Greek because he loves math.
And I hate it. No, but that's really cool. I'd never get, that's bonus. That's a bonus.
That's just to let you know. I mean, most people would not know that, but I'm saying.
I have never read it or seen it in any book.
It's
so
literally Greek.
Yeah. Fun. I'm going to share that from now on. I really am. Okay, so you guys, now you get a bonus. That makes sense. You guys can see, for example, a harness displaying the circuit numbers. I know it's a little bit hard to see. You can see right here, wiring diagram showing the connector numbers, right? So if you put all these together, you can see, oh, it's this circuit number, it's that circuit number, it's this connector number, C110, and this one's the male and this one's the female. Makes sense? There's splice 109. Now you're starting to see how much information was on that diagram. There's terminal number 1 and terminal number 2. There's another connector here. So if we had a problem on this wire, you know, you want to test that wire, right? One way to test that wire would be just take your meter and just stab it. Just stab it. Okay, but the problem is if you stab it, you broke the insulation and water's going to get in there and corrode it. And so you might have diagnosed it, but down the road, now the wire's going to fail. So we don't probe right there. What we would do though, if there's a connector like this one, C934, we would actually carefully back probe right here with just touching the terminal, not actually poking the wire. So remember these little tiny terminals? You can actually sneak your meter lead with a little tiny T-pin on it in and just touch the little metal right there. Nobody's stabbing anything. We're not hurting anything. That's how we test. That's back probing. Back probing is a skill in itself. But the wiring diagram will show you really where to back probe. Cool. Now remember I said there's a key? So I took a couple screenshots of a key. This one happens to be in the Toyota system. It really is cool when you're working for a dealership because the manufacturer gives you the information firsthand. When you're working for, well, technically, when you're working at the dealership, if a non-brand comes in, so let's say you're working at the Ford dealer and a Chevy comes in, you might use all data. But if you're working at an independent shop, you don't have access to the original manufacturer information. You have all data, who purchases it from the original manufacturer, and then they don't always get every single piece. If you're with the manufacturer, you have this whole key. So right here we go under like abbreviations or glossary of terms, wire harness repair, or terminals and connectors, and then next thing you know, boom, that's what a battery looks like. That's a capacitor. Here's the cigarette lighter. It's actually pretty dated, but that's a key to know what the symbols mean. Here's a few more symbols. So like switches, for example, there's going to be a lot of switches on your diagram. The state of the switch as shown on the diagram is normal. So like if a switch is normally open, that means it's open unless you push it. Does that make sense? What if it's normally closed?
That means it's always on?
It's closed until you push it, which opens it. Yeah. So don't think of it as on or off because it depends on how it's wired. It's either open or closed. Now, if it's normally open and it's in the diagram, and let's say it's for the headlight switch is normally open, right? You don't want the headlights on all the time. When you close it, you're actually turning the switch and closing it. Which position do you think you're going to test the headlights on? You'd have to close it though. Think about it. If it's open, the headlights are off, there's nothing really to test, okay? So in one of these activities, you're going to see a lot of what should it have if it's open, what should it have if it's closed, and I just noticed students tend to get a little confused because it's like, you don't really need to test it open and closed. If the customer's complaint is the headlights don't work, just assume you need to close the switch or they're not going to work. So even though it's normally open, we test it with it closed. You should, again, step back, engage brain before hands. Don't you tell me that the lights in the classroom don't. You want me to tell you if these bulbs are good or bad, but you want me to do it without even turning on the light switch? I can't tell. You got to turn the light switch on to even test these. Would you say that's true? Yeah. Okay, go ahead.
During the worksheets.
Exactly. Exactly. Yeah, you were doing it exactly, and I can see how, and I've seen it over the years where it's like, well, the switch is open, so we test it with it open, and it's sort of like, well, that switch over there is open too, but you can't tell me anything about the bulb until you close it, so yeah, just like that. Cool. And then I like these diagrams. This one is just, to me, is just a bit cleaner. So if you look, we start with our fuse here. What do we know about this fuse? Can you read it from back there? 10 amp. It's a gauge number 1 fuse. Cool. And then it comes out and it becomes a red wire and it goes to this connector, and the top of the connector is the female and the bottom is the male. And then it actually kind of goes female to male for another connector. And then it goes to this thing. What do you think that is?
Splice.
Yeah, splice. Looks like a stop sign, but that's a type of splice. Then it goes down here and it goes to this switch. What can you tell me about that switch? True, it's normally open. What's the name of it? Yeah, backup lamp switch. And sometimes it has a component number. So C28. So if you were to be like talking technical with a technical assistance, you'd be like, oh yeah, I'm on switch C28. And they're like, okay, yeah, I got you. Otherwise, you could say the backup lamp switch, whatever. It's either way is fine. All right, so right now, the switch is open. So if you were to trace this, you'd be like 12 volts goes down, 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 and then it stops, right? Because the switch is open. Would we agree? Yeah. if we were to actually want to test the backup lamp circuit, we'd really have to close this. And then you'd notice it'll provide the voltage to the lights to make them turn on. Okay, makes sense. So this is actually this is one that I'd like to trace just to give you a quick sample. We'll mix it up just a bit.
But the chevrons mean it's
Male, female.
direction going, or
It-
is it?
So good question. You when you guys ask, it shows me what you don't know. So don't be shy. The chevron is literally just the terminals, right? So I'm going to grab these terminals.
So it's not the direction.
I actually should have brought male, female, but I only brought 2 females, so this is incompatible. But right here, you can see that this one's a male. That would be the smaller terminal, and this one's the female. That would be the larger terminal, and the male terminal will go inside the female terminal.
That's the only thing. It doesn't-
That's it. It doesn't tell you which way the electrons are flowing or, none of that type of stuff. It just tells you which one's male, which one's female. So if I say, hey, let's diagnose this circuit and let's start with connector CA2, you can find connector CA2 digging around and be like, here's the connector, but I don't know which one's coming from the fuse and which one's going ultimately to the backup lamp switch. Well, yeah, you do. This male is coming from the fuse and this female is going toward the backup lamp switch, right? So that's how you know you probe the right places. You can test the switch in the right on the right side, basically. Cool. So this was actually not originally what I was going to do, but I've decided this is a fun wiring diagram, I think. So let's go ahead and we'll trace it. We usually start with the 12 volts, the power side. Where's the source of that on this one?
S1.
From the 10.
All right, let's say on this diagram, where's the most positive spot? I'll give you a clue. It's usually at the top. See this fuse? Well, before the fuse, there's a whole circuit, but that's like the power source diagram. That's like how it gets from the battery to there. We don't really care about that. If there's a problem from the battery to the fuse box, we have a whole lot of stuff not working. But let's just say the customer states, my backup lights don't work, and you want to diagnose it. This is exactly what you do. Pull the diagram up. Positive starts at the fuse, right? So I'm gonna highlight this. Would you agree it should go positive through both of those connectors? Yeah. Connectors shouldn't drop voltage, right? That's not the load. And then if you look, it splices, which means guess what? It goes this way and this way. Now pause right there. This is something that is in the diagrams that's not always well explained. This says backup lamp switch, and this says park neutral position switch. This one says MT, and this one says AT. What do you think that means?
Manual.
Boom, got it right off the bat. Okay, so let's say this is a Corolla. This is a Camry. I know because I know these engine codes. If this is a Camry, which is crazy because you never see a manual Camry, but if this Camry had a manual, you will disregard this. It doesn't exist on the car. You understand? This is a park neutral position switch. Have you ever put a manual transmission in park? There is no park. You might shut it off and pull the parking brake. That's not the same as click, right? So if you were to, my wife's into cars in a different way. She doesn't want to get real dirty, but she did help me bleed brakes the other day. She thought she wanted a GTR. How's that sound? Like a GTR, cool. And I said, you don't want a GTR. And at the time, I think that's when we had our, yeah, so the first car, I had a car that was a manual transmission Celica, and it was all right. It was a cool car. But then the thing was her sister went away to school, so they gave her the family car. And then, because we were serious enough where, they leaned on me a little bit hey, if you guys want to do this, you got to grow up. So I said, hey, yeah, you could take the Celica. So that was the first car she learned on. So she thinks that stuff is fun. Celica, 350Z. So the 350Z was a cool car, but then it was time to get a new car. So she's like, I'm with the GTR. Yeah, I have the GTR, need the GTR. And I kept trying to say, like, it was a big leap, but we ended up not doing it. I think you'll understand why. You don't want the GTR. It's automatic only. You know they don't have a manual new like a GTR, like a 2017 GTR. That's automatic, people. I'm just letting you know. And I'm going to define exactly how I would define that. So she went to the dealer, and they're like, you want to see the GTR? And she said, yeah, I'll have a look at it. And she said, but I don't think I want it because it's automatic. And you know what the salesman said? It's not an automatic. It's a dual clutch. And then she's kind of like, oh, really? So she thought I was wrong. And then she's like, yeah, let's check it out. And she gets in there, and then there's a shifter, and there's like a P symbol. And she's like, why does it have park if it's not automatic? Okay, I mean, that's just classic to me. I thought that was like the smartest thing anyone ever said. If it's not an automatic, it doesn't have park. If it has park, I'm just letting you know, paddle shift, dual clutch or not, it's got a P and an R and a D. The conversation's over.
Oh, okay. So you're talking about like those cars that have the
yeah, but you still put it in park. I mean, like, okay.
There's a Rogue.
Prindle, yeah, Prindle. We do. We call them Prindle.
I think a Rogue. I think I had a friend that had
lots of cars.
Like, had the one.
Sure. So does a Mitsubishi Eclipse. I mean, like, so does. Matter of fact, so does a Camry. The Soul, right? So, but those now you can have fun with them. But I'm just saying, if you see something where it says park and reverse and drive and sometimes neutral low, or sometimes you'll put it into M, and M is like manual mode. Sometimes it's S, and that's sport mode. One thing, if the engineer designed it right, an upshift should not be forward. An upshift should always be like this. Downshifts should be forward. But if you got a car and this is an upshift and this is a downshift, that's like really designed by a video gamer. That's a gamer car. GTR is a gamer car, so we totally shut it down. Didn't get it. Shoot it. Okay, fine.
I was driving my truck the other day in my Escalator, so I accidentally put, without like noticing, I put it, because there's, the after drive, there's another one. And I really never have known what they're for, so I didn't realize I put it, like I moved
in a lower gear.
I don't know how I lowered it, and so I was like, oh my god, my transmission went out, because I felt like the
Sure.
I really didn't want to drive on. But what is that for then? And so I had to pull it over because I'm like, fuck, my transmission. I'm like, dang, my transmission went out or something.
Yeah.
So
I'm gonna take you up on your offer, but I will explain it extensively at break.
Okay.
Deal?
Yeah.
Fair deal. Okay. So now that we're back on track, if the car has an automatic, it has this type of switch. If the car has a manual transmission, it has this. It doesn't have this. So it has either the AT circuit or the MT circuit. Now see, if the GTR came with an AT or MT, I already know I wouldn't have been able to hold her off. We would have bought a GTR. That was a for sure thing. But I said, hey, you want a manual, they don't make it, whatever.
So would you see that type of diagram?
It'll have, if the car comes with either, it'll probably have both on the diagram, which means, pick one, which kind of car are we working on?
Automatic.
Okay, if it's an automatic, we can just disregard all this, ignore it. It doesn't need to be there. It's just ignore this. Focus your diagnose over here. 12 volts comes down, 12 volts goes to here. This is basically saying if you put it in reverse, this is going to connect to this, which means the 12 volts will go like this, okay? And then, but back up for a second. If you're not in reverse, what happens? It's open. So if you're not in reverse, it's a normally open switch. The positive dies right there. Are your backup lamps going to work while you're in drive? No. Would hope not. But then when you do put it in reverse, it should continue. Okay, so we're tracing it like this. And then, should it drop any voltage on a switch? Like basically no. Like basically no though. So when we're tracing, don't worry about 0.1 volts, 0.3 volts. We're worried about like if it drops the entire source. Yeah. So here you go. Now look, I'm just going through connectors, so I shouldn't be dropping anything, right? Now if you look, this is empty. So I skipped this because we don't have a manual. It keeps going through the junction connector, would you agree? right here, right here. Now look at this, another junction. So shouldn't it go this way? What should happen here?
That's where it drops.
Exactly. And here?
That's where it drops.
Bingo. So if you trace this circuit, what do we get starting at the ground?
0.
So green is 0 to the splice, to here, to here.
0, 0.
Okay. This would be a officially traced circuit. Do you know why we would do that? We're about to go in for diagnosis. It's helpful to trace your circuit so you know what should be available. Do you remember how you did all those predictions? If you trace it, you've done your predictions. If I stab this meter lead somewhere, the color should tell me what it should have. If I stab the meter lead right here, what should it have? Because it's red. See why we trace it first? What about here? What about here? Here. Here.
It's all red.
Exactly. So once you do it red, you don't want to be under the car thinking about like, now what should it have here? You want to be like, look, I thought about it while I was sitting upright, not upside down. My shoes were still on. The blood wasn't rushing to my head, right? Handle all this business while the paper's in front of you. Then when you crawl your sorry rear end under the dash of that car, all you want to be is like, look, this is red and this is... Well, if I'm going to be up with the headliner, so it's sometimes uncomfortable. And then if I'm testing here, what should I have? 0, 0, 0, right? Now let's just give a hypothetical. If I were to probe here, I should have 12, but if I had 0, what's that tell me? Something's wrong, but then if I were to probe here and it has 12,
It's from that wire.
Open right here.
yeah, if it's got 12 here, but 0 here, you already got it.
Is that a splice or is it like a stop?
This is a splice.
So there's another wire,
There's no traffic here.
but there's a wire going that way.
Electrons wouldn't follow the rules of the road if you put a stop sign anyway.
I know, but there's another
Yeah.
wire going out there.
Yeah, so it comes like this and it splices and goes over. Now, it's possible that there may be something else going on there, but for our purposes, it's a splice. Why would they splice one wire to one wire? There's probably another one, but not in this diagram. All right, now bonus point. I'm just going to erase this. It's still supposed to be 12s all in there. Bonus point. It says terminal A and terminal connector 1 terminal A, connector 2 terminal A, or connector 1 terminal B and connector 2 terminal B. Which one does this car have?
Depends on the engine.
Bingo, that's the answer. So right here, it says 2GR. Now, I just happen to know, that's why it's nice working with a particular manufacturer. This is the V6 model, and the 2AR is the 4-cylinder model. So I would need, this is a Camry.
Oh, okay.
Yeah, just like your old Camry. Well, so it's nice when a Camry could have either one. It's nice when you work on a vehicle that doesn't have a lot of options because you won't have a lot of complications. But when you have a model that comes manual or automatic, it comes V6 or 4-cylinder, they're not going to give you 4 diagrams. They're not going to give you a 4-cylinder manual, a 4-cylinder auto, a 6-cylinder manual, a 6-cylinder auto. They're going to give you one and they're going to write little things in so you can do your thing, but it can be a little confusing.
Hence the A and the M.
And exactly, AT, automatic transmission, MT, manual transmission. And then the thing is, Toyota's funny about their engine codes. Like the domestics would just say V6, 4-cylinder, but like Toyota's like 2GRFE, 2ARFE, and you'd be like, you'd actually have to go back to basic auto class, pop the hood and see what the emissions label said, and you'd be like, oh, okay.
So basically, every diagram is going to look like that if it's automatic and transmission.
And manual, yeah. Basically, but on a lot of the new stuff, the manuals are dying anyway. There's not going to be a manual option, so it simplifies the diagram. Too hard to incorporate a lot of great hybrid and fuel savings technology on a manual. It's out front today, but we'll look at it later. Yeah, it's she went domestic.
Oh, yeah.
She's and she put all the miles on the car too. I barely drive it. You can give it your feedback. Tell you if you think she's got good taste. Okay, circuit connections showing a lot of information here. That's kind of like a summary. So terminal numbers, connector number tells you that there's a junction block here. If you see components inside of one box, that means they're part of the same assembly. So this junction box has what? What's this? And this? And close. This whole thing. That's your relay. So the control side and the switch side, that's all in this blue box, which is, so pretty much, yeah, that's like the fuse box. So if you're like, where is that relay? It's in the same fuse box as the fuse. And so the reason we don't really want to call them fuse boxes is because it's not just a fuse box. It's really a junction block. Fuses, relays, sometimes there's diodes. Sometimes the wires just go there to be connected to other wires. So like if you're on the assembly line and you go to take an engine out of a car, you don't actually disconnect every single sensor. All those sensors come into one harness and go to a junction block. You can actually just separate it from the junction block, fold it onto the engine, and then separate the two. So junction blocks are more than just fuse boxes or relay boxes. It's where all the stuff comes together. It's like, it's a major intersection for a lot of circuits.
Well, it has one fuse and one relay, but there could be amongst others, right?
There will be absolutely be many others. Exactly. So this doesn't tell you the details of the junction block. It just tells you they're both in there, but it's not showing you everything that's in there. And it gets to be, there's going to be a lot of stuff going on in that junction block. And other times it may say underhood junction block or engine room junction block or dashboard junction block or rear area module, which is like a junction block. So there's a lot of different names, but at least you know where it's at. And then you can see this is showing wire color. The wire color on the diagram is kind of love-hate. Like it's nice because you can see the wire color. Sometimes when there's a lot of colors though, it gets a little overwhelming. So you may prefer one or the other, I don't know. All data a lot of times has two options, black and white or color. Cool. And if it's black and white, it'll just list the color, which I'm gonna be honest, I tend to prefer. But then also it tells you this switch. So this switch right here is our focus right now. There is a bunch of different terminals on here, but it doesn't list them all. It's only showing us the ones that are relevant to what we're trying to do. What type of fuse and what type of relay? What are they labeled? Fog. So what do you think we're looking into in this diagram?
High beams?
Not high beams. Fog lights. Fog lights, fog lights, fog lights. So if you're troubleshooting tail lights, you're on the wrong diagram here. If you just want to look into fog lights, it's going to extract only the information you need to diagnose the fog lights. So if we look at this switch right here, this is the dimmer switch. It does high, low, flash, fog lights. So this is the same switch for high and low beam, but it doesn't show you any of the wires related to high and low beam, because if it did, it would be complicated. So they're thinning it out for you a little bit. You're diagnosing fog lights, start with this diagram. Now we could trace it, and we may come back and trace this one for fun. Let's see how we're doing. But these are all the players. If your fog lights don't work, could it be the fuse? What fuse? All right, remember you guys said if my fog lights didn't work or my lights didn't work, couldn't it be the fuse?
15A Bob.
And that's exactly why we look at the diagram. It tells you where the fuse is, what the fuse is, what it's labeled. Absolutely. Could it also be a relay? Yeah, because look, it's right there. Could it also be a switch? What switch? This switch. And it technically could be the switch in the relay too. So you're seeing you're going to see all the players in the game so that you can do like an actual diagnosis, not like let me list some of the things and not all the things, and then just start replacing the cheapest ones. That's not professional at all. You need to know all the players. Cool. And then from there, this switch is a little complicated. If you have the fog light switch on, it connects 11 to 10. Can you guys see that? So right here, you know, because off doesn't connect them, on does. So you're going to have current go in here and out here. So basically I'm saying this switch, when you turn the fog lights on, connects terminal 10 terminal 11 to 10. And so then you'd continue the trace. Then it goes down here on 17, and something interesting happens. In low, we're going to draw it, actually. But I'm not going to draw the whole thing. We're just going to draw the switch part. All right. If we're trying to diagnose this switch, and let's just say we have, oh, this is actually ground. This is a ground-controlled switch, so I need to change colors real quick. Okay, let's say this is supposed to be grounded, so I should really start from the other end. This is ground, we agree. Ground goes to here. And then let's just say we have it on low beam. Look what happens. If it's on low, see that line? This goes up. That's jumped. And then do we have the fog light switch on or off? You tell me. Well, it could be either one. Do you want to test the fog lights? Then you better turn the damn switch on. Okay, here. Okay, and then I'll just give you a bit of a clue. If this fog light relay has 12 volts all the time, and I just gave it ground, do you guys remember what it does to this coil thing right here? It doesn't heat. It probably does with the magnetize, right? So if it magnetizes, it pulls this over, and then guess what happens? 12 volts makes it through, and it goes, whoa, whoa, and then they're on, cool, right? So just, now we're focusing in a little bit more over here. What if I turn the fog light switch to the off position?
It'll cut off right there on the.
Right, it'll cut off. And so ground would make it to there, but ground wouldn't make it to here. What would happen to that relay?
Unmagnetized.
No more magnetize, and then this opens back up, and these go off. Yes? It should make sense. And then, what if, let's say you turn the fog lights back on, cool? But let's just say you put the high beams of the car on. Do you ever notice something interesting happens? If I put the high beams on, you see this? This ground comes up, but it's never connected to there. So you know what happens? It loses all the ground. So look, if your high beams are on, it doesn't connect to the HL. It only connects to HL if your low beams are on. Why do you think they did that?
So you don't blind other drivers.
Yeah, you're not supposed to have both at the same time. That's like a federal, I think it's DOT. I think Department of Transportation wrote regulation, hey, fog lights, great, but not fog lights and high beams. Pick one, can't have both. So they don't tell the customers, you know, people are like sheep a little bit. The older you get, the more you realize they just, and they do it. So they're not going to tell the customers, hey, the drivers, remember, if you want to use your fog lights, be sure to turn your high beams off because they're going to be like, So they build it in so that the second you put your high beams on, it kills the ground to the fog light relay, so your fog lights are off. Make sense? So some electrical engineer, higher IQ than me, figured out how to do that. What?
Electrical engineer boring.
I don't know. Maybe not for everybody.
Let there be light.
That's what my daughter tells me all the time.
She doesn't like it.
Oh, she's doing electrical course, so she hates it.
Oh, she is?
Oh my god.
Cool. Well, there must be something good about it if she's carrying on the tradition. Okay, you guys kind of understand how we did that? Because I'm going to give you a bunch of these and you got to be able to trace them, okay? Okay, now remember, when we're in the wiring diagram, you might have to click around and do some different stuff. And I plan to give you a quick little demo of that, because if I provide you the diagram, I believe you could do it. But if I were to just give you the customer car and be like, the fog lights don't work, a lot of times you get the deer in the headlights and you're like, I don't know what to do. Like, if electrical problem, start with the wiring diagram. But you got to find it. You got to navigate. You got to click on page. It might be a pain. Remember, I'm telling you, it might be a pain to find the diagram. Okay, and then there's a couple differences I want to make sure we point out. This is called power side controlled, and I'll explain why. Because this, I'll pretty much guarantee if I don't explain this, you'll be stuck. We agree this is positive, right? Yeah, this marker's all right. It goes to the stop lamp switch. If the switch is open, what's coming out? Nothing. But if we're trying to test the stoplights, Close the switch. All right, so this is going to close, and it goes 12, right? But before, it was 0 coming through. So what are we giving or not giving the bulbs?
The whole.
Actually, if you look, ground is there all the time. So what did we change when we pressed the switch? We gave it 12 volts or we didn't give it 12 volts. So therefore, it's a power side controlled. We're controlling the power side. See, the switch is on the power side. So we're giving it power or not giving it power. That's the difference, because the next one, which I think I can leave my highlighting, not quite. The next one is not going to be like that. Okay, so this next one, if we draw it, dome light. Have we seen a switch yet?
No.
So that means 12 volts is going to these bulbs all the time. Okay? Now what's up with ground? It's grounded right here,
Right here.
and then it stops, because look at those switches. What's the status of those switches? So technically, in this circuit, red goes all the way through the filament and it waits right there at that point. All right, if you were to look at it, why is the bulb not lit? No ground.
I mean, the car doors open, right?
Well, there's a couple ways. So like vanity lights, these are the ones that you can actually push. You know how you have the lights, you can actually push them and they turn on? The light contains the switch. So it's a light bulb and a switch. If you want this one on, what would you do? You press it. You know what that does? It closes the switch, which will actually make the ground, make it all the way to the bulb. Now the bulb will have 12 volts in ground, and yes, it'll be on. Make sense? This is ground side controlled. Can you tell the difference?
Yeah.
We either give it or don't give it power side, or we either give it or don't give it ground side. Depends on, you can do it either way. A lot of the Japanese really like the ground side controlled. I don't totally know the reason. Somebody explained to me that it causes less wear on the switches, but I don't know. That didn't really make sense to me, because it would be, even if it was electron theory, I don't know. If you think about something, let me know. But what he said didn't really make sense. I don't see why they would prefer the ground side control, but they do. Okay, the difference makes sense though? Kind of. Okay, actually I shouldn't have closed that. I shouldn't have pulled this down, because we're going to do this worksheet together. And then we're going to take a few moments and have you do a little practice, couple pages together. And then in my experience, this is what happens. I'm going to do this and you're going to be like, I got it. Then I'm going to give you the worksheets and you'll be like, I don't know. Okay, just predicting. Speaking of predicting, let's predict the voltages. Just 12 everywhere. 12. Okay, here we go. Well, there's a couple ways we could do this, okay? But what I'm going to recommend is let's trace it. And look, you see what this says? Switch what? So let's trace it with it open, okay? Should it keep going? No. Ground side. You know, here's what's kind of interesting. This ground will actually go through the element. And it would technically go all the way to right there. Okay? So this is traced with the switch open. If you do this first, this is going to be really easy. Where we're pointing to right here, what color is that? So what should it be? 12. All right, where it's pointing right here, what color is that?
Green.
And here? You see how tracing can make your life a lot easier? Right? I started you off early, like babies, with soft food, having you predict a little bit here and there. But now you should be like, hey, you kind of get it. But if you can get this traced, you're there. All right? If you can't, it's okay. We got a little bit more work to do, but you should be close. Now, what's the second task? Is with it closed. So we got to close it now. When we close it, the 12 volts comes through, right? So that means there's not going to be ground. Basically, I think of it like this. Remember I told you about the cars? the toll bridge was open, so all these cars were waiting. The second you close the toll bridge, all the cars rush forward really fast, don't they? Until they get to the obstruction in the road, which is like a stalled car, right? So the 12 volts, yeah, let's go. Oh, slow down. Let's go. Oh, slow down. So when the switch is closed and the circuit's active, it's working, it should really go before the load, 12 volts, and after the load, 0 volts. Sometimes I just look at the load and I'm like, okay, up here should be red and down here should be green, but that's only if the switch is on. Make sense? Now the switch is on, closed. So we're pointing here, it's red. What should it read? We're pointing here, it's red. We're pointing here, it's green. Okay, like you get it? Those were all correct answers. You think it's really complicated or no?
No.
All right. So when I give you, I just got to print this worksheet for you, but when I give you this worksheet, you're going to get to do a couple. I do have some highlighters for you, and then we'll meet back up and we'll do some review and we'll see how you're doing. Will you pause for me?
Get this together.
You got the blue all done?
I got a little bit of a greater substitute.
That control voltage there, okay. You should be able to go on to the next ones, okay? This one was fairly easy. We did that one. So your next one here, we did. You guys see this one, right? So you can look at this and you can see if you're right or wrong. So first, let's trace it with it open, which is going to be a little bit tough, but we could do. We agree 12 volts here. Goes through here, through here, through here. Did we do this one? Yeah, kind of. Okay. So far we agree. And if the switches are open, technically the 12 volts will go all the way to that point. Okay. And then in the current state with the switches open, the ground is connected to ground. It doesn't disconnect the ground, so we got to bring the ground up as far as we go. So you bring the positive as low as it will go, and you bring the ground up as high as it will go. But the thing is to look at, does the actual bulb, the load in this case is a bulb, does that have 12 volts in ground at each of the connections of the bulb? No, so the bulb's out. You agree? This is exactly what will happen if the switch is open. 12 volts will go into the bulb and come out of the bulb and just be waiting there. Make sense? So if we were to fill this in, switch open would be what? 12. Switch open would be 0. And switch open would be 0. Okay. Then if we close the switches, if you guys
The
will,
top one would be 12, right?
the top one would, yep, the top one would still be 12. So I'm going to draw it exactly how it would be if we close, let's say all of the switches. Okay, this switch would be closed, so it would connect to right there. Connect to right there, connect to right there, connect to right there. Now this is more in its normal state, right? If you're really trying to test it, you're gonna test it with the switches closed, and you'll have 12 volts making it right to the bulbs in all cases, just like this, and you saw that. And you'll have ground making it right to the bulbs in all cases. So this bulb has everything it needs, which means it does what? It should illuminate, exactly. These should glow. Now let's just say this one doesn't glow. Now do you understand how you'd proceed on the troubleshooting? Or let's just say neither of these two glow, right? If this bulb works, we don't really need to check anything. If this bulb works, we don't need to check anything. But if this bulb doesn't work, we'd need to take our meter and we need to put the red lead up here and make sure that we have 12.6, right? If we don't, this should be 12.6. You agreed because we were filling these in. Oh, and you're right, Priscilla. I missed that one. When it was open, it was 12. While it's closed, what should it be? 12. It's still in the red, right? So it should be 12. And then with this closed, it should be 0. With this closed, it should be 0. So that's kind of interesting.
So it didn't change anything.
Nothing really changed because we didn't have the test points there. But what if I were to have the test point be right here? It was 12, and after I close the switch, it becomes 0, right? We just can't really test inside the box because that's the lamp assembly, okay? But bear with me on this. If this did not work, the customer says, my personal light is inoperative. And you'd have to be like, well, what am I going to sell them, right? So you get the diagram, trace the diagram. If this up here is terminal, let's go with a black marker. If this is terminal 1 and this is terminal 2, terminal 1 should have what on it and terminal 2 should have what on it?
12.
1 should have 12, we agree?
And the other one's 0.
And the other one should have 0. But what if, so you predicted good voltages, but what if you were to have measured it, now you'll understand why we're coming like this. What if you were to have measured it and you weren't to get 12, you were to get 0? Does it need a new lamp?
No.
It's not getting what it needs, which would mean you'd have to trace further up, right?
Yeah.
So the purpose of the tracing is just to make sure when you go on the car, you're doing your measurements and you're very quickly able to tell if it's a good or bad measurement. Terminal 1 should have 12. If it doesn't, whoa, hold up, something's wrong here. Then if you were to go up here, what should this have?
12.
And if it were to have 12 here, but 0 here, you'd have to sell them a repair on this wire or a new harness or whatever. Cool? That's the whole reason we trace. Now that you've understood why we trace, let's go ahead and we'll knock out the next trace. Just as a review, and then I do have more things for you to trace. And then we do have to roll straight into connectors and harnesses. So I'm sorry, but you'll get a really nice break at 1. Here we go. You ready? You got this. Let's trace it. Good. With it open, what should happen? Stop right there. Which means open.
12.
And then after that, we kind of start at the ground side. And this ground will actually go through.
0.
It wouldn't be because the 12 died right here with the open switch. Yep, so this ground would go through. They would splice together. The ground would go to the noise filter. The ground would go up, over, and down. And believe it or not, there will be ground all the way up here at this switch if the switch is open. Now, a lot of people, if they were to do this diagnosis, would be like, you know, if you were to do this diagnosis, okay, let's zoom in, and here you are under the dashboard, and you probe terminal number 1 of the stop lamp switch, and you probe terminal number 2. If the switch is open, what should they have?
12 and
12 and 0, and that would be correct. That would be a correct with switch open. A lot of people wouldn't expect to see ground way up here. You think that ground exists only after the load. Well, that's true if the circuit's active, but if the switch is open way up here, there will be ground all the way on the what you thought was the positive side of the load.
And when you close it, you would get positive through instead. Right?
Exactly. So let's finish up the opens. It's green, right? So you already know the answer is 0. Anywhere where there's green, it's 0. Did I miss anything? It's 0. Okay, now let's change it to closed, which changes a lot. So I'm going to try to draw it just how it would happen. I'm going to sacrifice the cleanliness of my hand for you. When this closes, positive tends to kind of like, think of it as sort of pushing the negative away. You see how it's changing over? Yeah. Now I want to pause right here because there's something complicated going on there, but we'll continue because this is a splice, right? Goes right to there. And this positive is going to continue to clear that ground right out of there.
and it stops at the load, right?
Exactly. It's so the way that I've always liked to picture this is like if you had a toll bridge and the toll bridge was up, all the traffic stuck here. But there's still these stalled, broken cars down here. The second you close the toll bridge, the cars rush forward, but then they stop at the stalled cars. Okay, so these stalled cars were here. They just acted differently when there was an open toll bridge at the switch. Go ahead.
Does the positive go to the tail fuse?
Right.
Yeah, I don't see anything stopping it. So yeah, it should be all the way. Oh, I see what you're saying. I don't know all what's going on there. It didn't really explain that. And I'm gonna say no. I mean, it's not connected.
Well, I'm saying because do the stop tail.
Sure, but you don't get to add anything that's not on the diagram. Do you see a connection here? I don't either, so I'm gonna say no. Makes
So it's
sense?
not connecting at the stop tail light, the stop.
Well, if you want to redesign it, we got to actually put something here and make a splice, right?
No, it's going through the
Or is it just pointing those out? That's not a
yeah.
wire.
That's just
The black line is going up.
Oh, I see what you're saying.
Yeah.
Where's the black line going up?
On the tail.
On the tail because
It says tail fuse.
it's going through the bulb. It's
Pointing
going
up
up.
toward
And
the
they keep going
tail
up.
fuse.
Right here?
No,
Go down.
go across right there.
No.
Nope. You're doing it right.
Okay, I got you now. This is just pointing out if you go to the stoplights, there's stoplights and taillights. So you're going to see a wire right here that's the tail light, and it goes where? But that's not really what we're looking at right now. What are we looking at? Stop. Right, it's just letting you know these go to the tail fuse. If you want to troubleshoot the tail light, go look at the tail light fuse.
The electricity doesn't go through the bulb up, right?
No.
Okay.
This is, you see that there's no connection here?
Yeah.
Don't add it. There is none there. So nope, it dies right there. And then I realized I actually missed just a little bit because the ground is spliced right here. See, that's a splice, right? We agree. So if it's spliced, then the ground is legitimate. Okay, cool. So technically, ground is going to go to here. 12 volts is going to go to here. And that stop lamp should glow. But look at this tail lamp element.
Yeah.
It doesn't really work that way. Like 12 volts is going to go to here into ground. It doesn't make its. This is if you turn on the tail lights, then 12 volts would come down here, and it would make that element glow a little bit less, but it doesn't have it. You see what I'm saying? So this is a dual filament bulb. Now we're getting there. If it's a dual filament bulb, the bright half will glow when you hit this. What's this? You press the brakes, the bright one glows. That doesn't mean your taillights are on. Your taillights are this little element, and your brake lamps are a bigger element that glows brighter.
Your headlights on your tail.
Exactly, and if you want your taillights on, you got to turn your headlights on, but it has nothing to do with this.
Stoplight, that's brighter.
Bingo, exactly. Okay, so if you've drawn it like this, your answer's gonna be right. So we'd start with this number with it closed should be 12. This number right here should be, well, look where it's pointing. 12, and a lot of people got stuck there, I know. So just wait for me. How about here? Switch closed? 0, right? Because you're just going off the color now. If you get the color, you're good. And here, 12. Okay, now what all is going on here? The noise filter is here for a specific purpose. When you send voltage and then you don't send voltage and you send, there's this switch and it's closing and it can tend to make like a little voltage spike. So when you open this switch, this can end up kind of spiking. And so this is a way for this positive to sort of like jump the little gap in here in the noise filter and get rid of any a voltage spike. So this is just for a voltage spike. Now, is it connected? No. Do you see the gap? This is a capacitor. So the red doesn't connect to the green. But if the voltage was high enough, it would actually arc. That's kind of how we look at it. The electrical engineers probably have a much more fancy explanation.
Yeah, I do.
Okay, give it to me.
The noise filter is there to filter out AC. Capacitors are basically DC blocking devices. So if you apply a DC voltage on the top, it's not going to go right through. Okay, but if you have an AC signal of any kind that the wire picks up through RF interference or whatever it is, it will go right through. And the whole idea for doing that is so that you ground, so that all the AC signal will go into ground and it will disappear. That's why I call it a noise filter. You're taking out the noise
The AC
from
in
that
there.
whole circuit.
I see.
So it's not only for spikes. No.
I gotcha. Cool. Good to know. I'm glad I'm talking with you. Tim has given us the technical on the AC, the noise filter.
What a noise filter does.
Just jump it.
Well, that's what I would do.
Just jump it.
That's what I would do. Okay.
Sorry to interrupt everybody.
You do what you gotta do. So how'd you guys feel on those diagrams?
Good.
All right, you're gonna have more diagrams, but for now we're gonna actually switch gears and we're gonna do connect. All right, to continue the wiring diagram and the circuit tracing, we're going to use this. This happens to be the rear door locking diagram for an old Camry. So let's cherry pick this diagram apart here. You can see the fuse, you can see the connectors, you can see the switch. This is the unlock and lock switch. So if you throw to unlock, that's going to move this switch over to unlock and connect right here. And if you throw to lock, that one stays to the left and lock would move over here to the left. All right, so let's just say, let's test it in the lock position. 12 volts is going to start at the top for our source. In fact, if we were not in the lock nor the unlock position, it would do this. All right, you guys can see that. Then if we were to put it to the lock position, this little switch would end up over here. Agreed? So that would be connected. 12 volts will come down. 12 volts will come over. 12 volts will go up. And that M right there, that's the lock motor. So that's how it locks. So we know that much. We could also say the ground would start here. The ground would go over. And this is where it gets really interesting. The ground will go up. Okay, let's see if I can get to focus. Yeah, that's happier. And remember, this is no longer open. This is no longer closed. This is moved over that way. So the ground would actually go this way and down and down and down and here. Cool. So let's just say hypothetically that made the lock go this way, counterclockwise. Then if we were to switch it the other way, which I can do, just like this, we would put it in the unlock position. Goes to here and here. Then now your unlock switch has moved over here. So it's going to go this way, this way, this way, and down. And then your ground is going to come from here, go to here, go to here, and then notice this lock switch is this way now. Now that looks the same, but it's not. And the reason why, because it's opposite directions, right? So here you have going through the lock position, it turns the lock motor counterclockwise, and through the unlock position, it reverses polarity through the switch and turns it clockwise, right? So lock, unlock, lock, unlock. Same components. What's fun about this diagnosis is if you had, let's say, a lock that would lock but not unlock, you'd think, could it be a wire or whatever? And actually no, because this wire is the same, whether it's lock or unlock, and this wire is the same, whether it's lock or unlock. If the door lock locks but won't unlock, it's really just got to be the switch. If the door lock locks, this switch works, but it won't unlock, then this must have a bad contactor. So just understanding your diagnosis can be complete. All right, but let's pick another one. How about, yeah, we'll go with this one. We have to actually zoom out just a hair, okay. Even maybe a hair more. All right, let's run through this. 12 volts out of the battery to here. It Y's off, it goes to here. to here. It's as much as we know. We don't know what's up yet. I do know that the ground starts down here, goes to here to here. That's all we know. Now, what position should the switch be in? Depends. Let's say that we're testing a customer's car for a problem with the headlights. Well, then logically, we would need to have, in fact, what is this diagram for? Yeah, headlights. If you look, this green one is going to go up through here like this. If you want to test the headlights, you need to put the headlight on. So see the head button, that's headlights. It's going to go here, which is going to go up, ground. Okay, we're not really sweating the integration relay a whole lot, but it is going to provide ground to this. Now, what can we determine from that? Look at that. That's a relay. That relay coil, if that has 12 volts in ground, this gives off a magnetic field, which will pull the switch side of the headlight over, of the headlight relay, right? So if that switch side is over, now 12 volts will pass through because the relay's on. Oh, and for the record as well, we know that there'd be ground down here too. Right, so the 12 volts will now pass through. 12 volts will go here, here, down. There's no loads, so 12 volts should make it to there, to here, to here, to here, to here. All right, it should. And then from there, here we got a ground way down here. Should send that up. Logically, to the bottom of the bulb, and that's it. Why not over here? Well, I looked. There's no splice here. So we would currently have this headlight on, this headlight on. This would be a no, this would be a no, this would be a no. And that makes sense because we have the low beams. This is a low beam and that's a low beam. All right, but what if we were to go down here to this switch and we were to turn the high beams on? That would send the ground would go to there. So this is a ground controlled switch. And as you can see, if the high beams are on, it connects this switch right here. So it goes here. Now, once we turn the high beams on, look at what ground does. That would mean this right side high beam will glow, left side high beam will glow, or sorry, left and then right. And then this right here is the indicator. So this is that little blue light in the dash, that'll turn on. That's how your high beams work. Why do we want to know this? Well, again, let's just say that we had high beams and op. Well, we would trace this and then we'd come in and we'd check for our voltages. And if we were to check, let's just say terminal 1 right here of the headlight high beam, and we had 12 volts right there, that would be good because it's in pinks or pink or red, that would be good. And we should have ground here, but let's just say we got a reading of right here, we got a reading of 12 volts. That would be like, uh-oh. If it's green, it should have 0 volts. Why does it have 12 volts? Well, we might have to go a little further. Maybe we have 12 here. Maybe we have 12 here. Maybe we have 12 on terminal 12 of the headlight switch back probed in the vehicle. That would mean this switch is not giving ground. But if we were to check 9, and we were to have 0 volts, that means this ground is good. It's just that the switch is not passing ground through from terminal 9 to terminal 12. Bad switch. Or let's say it was slightly different. We had 0 volts here. We had 0 volts here. But we had 12 volts here. That would mean the 12 volts is making it through the load and then dropping it here because there would be an open in the wire at this connector ED1, right? So tracing is helpful. It helps you understand the circuit, but also once it's traced, you know you can just jam your meter on everywhere that's red and it should be 12 or source. Jam your meter on anywhere that's green, it should be a good ground. Cool. So there's a couple walkthroughs for you. That one explained a relay too, so that one is good. Power seat. Yeah, you know, I think that's good for the walkthroughs. I might do another walkthrough later, but I think for the initial lesson, I think that should be pretty good. Well, I'll tell you what. Let's do one more just so I can give you an alternative way to look at this. The alternative way to look, there's a lot going on this one. The alternative way to look at this is, let's identify the loads. Load, 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 load. Is that it? Looks like it. All right, cool. So if you identify the loads first, the next thing you could do is run the grounds. It's another way to do this. And if you notice, there's a splice right here, so that ground comes up. All right. Everything after the load should be ground. Then you could pull from the positive. Should go to the switch. Should go, oh, there is a load right there. That little thing snuck up on me. Should go positive here. Well, I can't trace that green because I don't actually know, but in theory this could be ground, but you notice it doesn't go to ground. So actually, it should be no. Basically what I'm going to tell you is understanding the circuit, well, we'll come back to it. All right, this switch, this is the stoplight switch. Have we applied the stoplight? Yes or no? Well, in this case, let's say, yes, I just pushed the brake pedal. 12 volts should go through. 12 volts should go through into here. From there, it actually goes through this, which is interesting because it does have a little resistor there. If we've applied the stoplight switch by pressing the brakes, we should have 12 volts here. Yes. And let's see. It also, oh, there's a splice right there. Look at that. Here we go. Should have 12 volts, 12 volts, 12 volts, 12 volts. All right, we should have all those. All right, and so this is the center high mounted, and these are the right brake light, left brake light, right brake light. All right, but what's going on here, this device it basically determines if there's a failure sensor. So the exact circuitry inside of here, I don't always know. You know, I really don't. I can see a transistor here. I think based on what it sees, the transistor, and this is positive, by the way, that transistor can connect or not connect. So let's just say the transistor connected for whatever reason. Notice right here, this in here would be a ground. If it gave ground, that would supply this with ground. So if this light failure sensor passes ground through, it'll give ground to right here, and that'll illuminate this. Can you see what that is? Rear light warning light in combination meter. So if you have a rear taillight out, this basic relay, this basic logic component will give ground and make your warning light come on saying, hey, you got a taillight out, basically, or a rear lamp. May actually be a stop lamp like in this case. All right, so that's another way to go about the wiring diagram. I think overall, you're probably pretty good. I guess if we were to put this into practical application, if you were to measure, let's say, 12 volts, well, how about this? If you were to measure 12 here, ground here, and that bulb didn't work, what would be wrong? The bulb's getting 12 volts in ground. It has everything it needs. If the bulb doesn't work, the bulb is bad. If this bulb next door, you were to measure 12 here, and then you were to measure 12 here, that bulb wouldn't be bad. 12 volts is passing through. It would mean it has an open ground. If you get 12 volts on the bottom side of this, that's an open ground. Where? Well, the fact that this, after you put this bulb in, let's say it fixed it, it glows. that means you know this ground is good, this ground is good. So it actually need to be an open between here where it's 12 volts and here where it's got to be good ground. We know it's good ground because this bulb is lit now. All right, so you can really slice this up a few ways. But I think with that, that should be probably pretty solid on wiring diagrams. You get some more practice, and I may do one more little demo here on the computer. All right, so this may be helpful. So this is a wiring diagram, and I did try to match the vehicle up. It's not quite right, but let's just say you were trying to do some work on the throttle body. Pull this diagram here, and if you notice, here's your throttle body. These two wires control the motor. You know, so if you were, without getting into engine performance, let's say you had a concern about terminals 1 and 2, there's a couple things you do. If you could just look at the wire colors, you'd probably find it. But if you wanted to know for sure, this is a Toyota specific system, but I think you'll find it really helpful. If I click on this, I can get information on this, and boom, baby, there's your connector end view. And the connector end view is from the front right here. So if I was concerned about 1 and 2, 1 and 2 are the left ones right there. Makes sense? So what I would do, this is not so much about back probing right now, but what I would do is I'd actually slip a back probe in through that seal, get right down in there. Not recommended to be shoving stuff in the front. Don't be front probing stuff like this, but back probe it. So the connector end view, especially on these larger connectors, is going to be critical. So if I were to back up, now the throttle body you could have probably figured out, but let's say you needed to check it up here on terminal 29 and 20. I don't know how those look. So I would select and find connector end view. 29 is here, and 20 is here, right? So those are kind of much more difficult when it's like an ECM connector. So this is called connector end view. This is going to be critical. All the manufacturers have it. They're just different ways to locate it. So this shows you how it depends on what program you're using, all data or whatever. What's also helpful is sometimes these will show you even all the connectors. And what's really nice on this was, I think it was, I don't remember if it was C1. Let's actually back up because I wasn't paying enough attention. Here we are. Let's find that throttle body again. Here's our throttle body. Let's focus on 29. 29. And that's G. Do you notice that G? If you look, there's G. So that tells you what connector it is. Let me turn that off. That G tells you it's in that connector G. And then it's terminal 29. So let's click back on that because the ECM had several connectors. So if it's G, if we were to look, E9, E10, okay, they're going by the E's, so I actually have to jump back again. Let me zoom in here. Let me scroll over. Chill this out a little bit. Now, the throttle body, I must have passed. Did I pass the throttle body? It's the problem on some of these bigger diagrams. There's a lot of stuff going on. Okay, here's our throttle body. Yeah, so it's G, but if I look, G is E11. So see, E11 and G are kind of together. So I need to jump back in here. I need to go to E11. So there's E12. So E11, and that was one of those terminals was terminal 20. So I was actually pointing to the wrong one earlier. If you wanted to point to terminal 20, you can actually select it right there to save it. All right, so let's say we're trying to track 20 down. You don't know where it is. Instrument panel position of parts. There's that connector E11. Follow it down here, there it is. So you can also use a locator and say, okay, I need to pull off like the glove box and go to that second from the top connector on the ECM. Then that's when you'd really get down to business, because now you know where that connector is, and you know it was E11 and terminal 20. So now you can accurately locate that particular terminal on the vehicle, and based on this diagram, you should be able to tell at terminal 20, that's the motor positive, so you could test it, right? So there's actually quite a bit that goes into the wiring diagram and connector end view and locating it, and there's a lot. Now back probing and everything, that's going to be on the car. That's a different thing. All right, so this will wrap this one up. This should be everything you need to know.